We can peer so far into space that we can trace the universe almost back to 13.8 billion years ago, just a short time after the Big Bang. Popular sci-fi movies and religious texts, like the Bible, often point to apocalyptic events. But what if the end of the universe mirrors its beginning? The James Webb Space Telescope has made an astounding discovery. The universe has stopped expanding. A prediction made years ago by scientist Brian Cox suggested this outcome, and it now provides us with a compelling way to imagine how the world might end. We can look at the oldest light in the universe, which emerged before galaxies formed. This light is some of the strongest evidence for those who doubt the Big Bang theory. It serves as a glimpse into the universe's early days, taking us toward a second Big Bang. Join us as we examine why the universe's expansion has ceased and explore the frightening implications of the James Webb's revelations. If there's one thing we can be sure of in understanding the universe, it's that our existence centers around an event known as the Big Bang. Alternative theories like eternal inflation or the oscillating universe also offer explanations for the universe's origin, but today we focus on the widely accepted Big Bang theory, as this is the narrative most astronomers believe in. While the Big Bang is well known in astronomical circles, the vastness and intricacies of this phenomenon are often beyond most people's comprehension unless they've spent extensive time studying simulations and visualizations. To clarify, the Big Bang wasn't just an explosion, it was the origin of everything. Essentially, it began from a singular point that was infinitely hot and dense, and then inflated rapidly, expanding the universe to unimaginable sizes. At the time of the Big Bang, the universe was just 10 to the power of minus 34 seconds old, which is a fraction of a second. It was during this brief moment that the universe went through an enormous burst of growth, referred to as inflation. This expansion happened so fast that space grew faster than light itself. In just 1 second, the universe grew 90 times larger, from subatomic to roughly the size of a golf ball. As the universe continued to expand, it began to cool, and this cooling allowed the formation of matter. At this point, particles like protons, neutrons, electrons, and neutrinos were created, laying the foundation for everything in the universe today. Although we understand a lot about the Big Bang, our understanding is still largely theoretical. Science has advanced tremendously since the moon landing, and our technological progress has been exponential. But back when scientists were only studying the Big Bang through equations and models, they never could have predicted that we would one day be considering the possibility of life on Mars. Despite huge strides in space exploration, our technology still has its limits. For example, we can't recreate the Big Bang, nor can we observe it directly. Our best evidence comes from the cosmic microwave background, which gives us a glimpse of the Big Bang's aftereffects. While this has been a huge breakthrough, it's important to note that it has limitations. One of the biggest issues is that we can't observe gravitational waves or the residual radiation from the Big Bang's expansion. Our knowledge of the universe's origins, while largely accurate, is still based on theories that are vulnerable to errors. However, there's a great deal of evidence supporting the Big Bang theory, and it's difficult to dismiss entirely. In recent years, we've relied heavily on the Hubble Space Telescope to study the universe, but now the James Webb Space Telescope has taken things even further. The James Webb Telescope brings more precision and clearer images, allowing scientists to expand their understanding of the universe. In past decades, one of the most widely accepted concepts was that the universe is expanding. If you had opened a science book from the early 1990s, you'd have read about how the universe was getting larger. This expansion has long been one of the most established facts in cosmology. But the James Webb Space Telescope has challenged this belief. It has found that the universe may have stopped expanding altogether, which is a significant shift from what we thought we knew. This breakthrough was made possible by studying new images captured by the James Webb Space Telescope. These images show that light waves are curving, indicating that space itself may no longer be expanding. The data reveals something even more profound. The universe is shaped like a sphere, with both space and time contained within it. These revelations provide crucial insights into the universe's trajectory, suggesting that the expansion we once thought was happening is now a thing of the past. While the Big Bang is still accepted as the universe's origin, the new data complicates our previous understanding of its expansion. The new pictures reveal that the universe's growth has halted, and this could be a sign of its inevitable fate. Scientists have long speculated about the universe's eventual collapse, and this discovery supports the idea of a big crunch, a scenario where the universe might collapse back in on itself. To understand the implications, we need to revisit the concept of the Big Bang. The universe began as an infinitesimally small point, and from there, it rapidly expanded outward. This expansion happened at an extraordinary speed in the beginning, but as the universe aged, this rapid expansion slowed down. Initially, scientists thought that the expansion would continue forever. This idea was tied to the assumption that the universe's expansion would never cease, allowing us to hypothesize how the universe would ultimately come to an end. However, the James Webb Space Telescope has altered this perception. According to the latest data, the expansion of the universe has dramatically slowed, and it might have already stopped. The images from this telescope suggest that light is bending as it travels through space, and this bending is a sign that space itself has stopped expanding. This discovery contradicts the previous assumption that the universe would continue to stretch forever. So, what does this mean for the future of the universe? The most plausible scenario now seems to be the Big Crunch, in which the universe slowly collapses in on itself. The images from the James Webb Space Telescope suggest that the universe has reached the peak of its expansion and that it is now on a path toward contraction. This idea is not new. Scientists have long theorized about it. But now, with the evidence from the James Webb Telescope, we have confirmation that the universe may eventually collapse in a manner similar to how it began. It's mind-boggling to think about the universe potentially folding back in on itself, but the data from the James Webb Space Telescope makes it seem more and more likely. The curvature of the universe shown in these images supports the theory that the universe is a sphere, and its expansion has reached its limit. From here on, it's believed that the stretching of space will slow and eventually stop, leading to a collapse. Scientists are now able to study this process more closely, and the discovery that the universe's expansion has ceased brings us closer to understanding its ultimate fate. While this discovery may seem like a harbinger of doom, it's part of the natural progression of the universe. Whether the universe will collapse in the next few centuries or in the distant future is still unknown, but one thing is certain: our knowledge of the universe has reached an extraordinary point, and this understanding, though unsettling, is key to predicting the universe's ultimate end. This groundbreaking discovery from the James Webb Space Telescope has opened up a new chapter in our understanding of the universe. What was once an established fact, our universe's continual expansion, has now been turned on its head. The realization that the universe has stopped expanding is both a shocking and profound shift in the field of cosmology. Scientists are now confronted with the need to rethink everything they once believed about the universe's trajectory and its eventual fate. The potential end of the universe through a big crunch is not a new theory, but it's one that had remained speculative until now. For decades, we have imagined the universe stretching outward indefinitely, driven by dark energy and the expansion of space itself. However, as the data from the James Webb Space Telescope suggests, the expansion has reached its limit. If this trajectory continues, the next phase will see the universe begin to contract, reversing the process that began with the Big Bang. What does this contraction mean for the future of the cosmos? The Big Crunch is often envisioned as the ultimate collapse of all matter and energy back into a singularity, a point of infinite density where time and space may cease to exist as we understand them. If this theory holds true, it would mean that our universe is not an eternal, ever-expanding entity but a cyclical one, with each expansion followed by a contraction, ultimately leading to the collapse of everything we know. In many ways, this understanding brings us closer to the universe's inevitable end. But at the same time, it forces us to confront the limitations of our knowledge and the unpredictability of cosmic events. Even with the most advanced telescopes and observational tools at our disposal, there are still so many unknowns about the universe's ultimate fate. One of the most important takeaways from the James Webb Space Telescope's findings is the realization that the universe is not static. The very fabric of space itself is dynamic, constantly evolving. What we once believed to be a simple, ongoing expansion is actually a much more complex process, shaped by forces and phenomena that we are only just beginning to understand. Whether the universe will eventually collapse in on itself in a dramatic big crunch or follow a different, more mysterious path, the data we've collected so far is reshaping our understanding of the cosmos. In the meantime, the fact that the universe has ceased expanding also raises questions about the future of space exploration. If the universe is no longer expanding, what does this mean for the distant future of our own galaxy and the larger cosmos? Will stars continue to form, or will the contraction of space have an impact on the formation of new celestial bodies? These are questions that will occupy the minds of scientists for years to come as they try to piece together the puzzle of the universe's destiny. The journey to understanding the universe's end is still in its early stages. The discovery made by the James Webb Space Telescope has only scratched the surface of what may lie ahead. As we continue to observe and analyze the data, new revelations are likely to emerge, each one offering more insight into the nature of our universe and its eventual conclusion. At this point, it's difficult to predict exactly when the universe's expansion will cease entirely or when the process of contraction will begin. Some scientists speculate that the collapse may occur in billions of years, while others suggest that the process could begin sooner than we think. Regardless of when it happens, the idea of the universe's eventual collapse is a humbling reminder of the finite nature of all things. The James Webb Space Telescope's groundbreaking discovery has not only rewritten the cosmic rulebook but has also raised profound questions about the nature of reality itself. How did we get here? What lies ahead for humanity and our place in the universe? These are the questions that continue to drive the pursuit of knowledge in cosmology. As we look deeper into the cosmos and continue to refine our understanding of the universe's past, present, and future, the mystery of our existence only grows more fascinating.